Someone once told me, Kuya Ems, I've changed. Then I asked, physical or chemical? Good day, my dear viewers. I'm Kuya Ems and welcome to Chocolate Lapis. This is Agham Synthesis and you're watching episode 4 of our 20-part chemistry series. Our topic today, physical versus chemical change. Haircut versus burn. Everything in this world can change, but in chemistry, not all changes are created equal. There are two kinds of change in matter: physical change and chemical change. A physical change only alters the appearance, but the substance stays the same. A chemical change, however, creates a new substance. It's like a total identity transformation. What is physical change? In a physical change, what changes is the shape, size, state, or appearance, but the substance itself stays the same. Even if you zoom in to the molecular level, the particles are still identical. No bonds were broken or formed. Common examples: the melting of ice. It's still water or H2O. Crushing of stones. Cold air becoming more dense. Getting a haircut, and many more. In physical change, only the intermolecular forces are affected, not the chemical bonds. Let's go to chemical change. In a chemical change, the change goes deeper. A chemical reaction happens which creates a new substance with different properties. Common examples: burning of wood, which turns it into smoke, ash, and gas. Rusting metal, which happens when iron reacts with oxygen. Cooking an egg, the change causes the proteins to break and recombine. Fermentation, which happens when bacteria change sugar into acid or alcohol. Chemical changes involve breaking and forming of bonds, and the result is usually irreversible. But how do you tell the difference? Here's a simple cheat sheet. Physical change: no new smell, color, or gas. Often reversible, and molecules stay the same. In chemical change, there is a formation of new gas and bubbles, new color or smell, gets hot or cold, and usually irreversible. Pro tip: reversibility isn't always the test, but it's a strong clue. If you need a lab to undo it, it's probably chemical. Let's clear it up more. Haircut: that's a physical change. Your hair is shorter, but it's still chemically the same. Burnt hair: chemical change. The keratin broke down into new compounds, and you can smell the evidence. Even dissolving salt in water is a physical change. The salt doesn't disappear even if you cannot see it, and you can still recover it. But fireworks exploding? Definitely chemical. Energy was released, and new substances were formed. In summary, physical change is a change in shape, form, or state. There is no change in the substance. Examples are melting, cutting, and crushing. Chemical change: new substances with new properties are formed. Involves a chemical reaction, and common examples are burning, rusting, and cooking. But always remember, Not all change is visible on the outside. Sometimes you have to look within. If you had fun or learned something new today, don't forget to like, subscribe, and click that bell icon so you never miss out on our fun new episodes. We've got more adventures coming your way. History, science, and math, all with a twist of nerdy fun. I'm Kuya Ems, and I'll see you in the next one.